So far we've done exponential equations where we were able to change them to the same base. I'd like to talk a little bit about how to solve exponential equations using technology. So we've done a little bit of this when we were doing stuff with ease, but we're going to do a little bit more. So for our first example, we have 2 to the x equals 5. There are several ways to solve this one. I'll show you how to do it doing it partially by hand and then using a calculator and then using a graphing utility. So my favorite way to solve this type of problem is to take the natural log of both sides. So I'm going to take the ln of the left side, I'm going to take the ln of the right side. The reason that I like to do this is because whenever I have a exponent inside of my logarithm, I can move that out front. So that's going to give me x times ln of 2 is equal to ln of 5. And if I divide both sides by ln of 5, I get x equals ln 2 over ln 5 over ln 2. And I can evaluate that using a calculator. It's going to be approximately equal to 2.322. So that's one way to do it. There is another way to do it that is kind of interesting. We can actually evaluate this by using either Desmos or your graphing calculator. I know that not everybody has a graphing calculator, so I'm thinking either way that works for you. We're going to use just a graphing utility in general. And to solve this by using a graphing utility is we're going to, if you use your calculator, you're going to put in y1, you're going to put 2 to the x. In y2, you're going to put 5. And then you're going to find the point where these two things intersect. So what will happen is when you graph this, you'll get the 2 to the x is going to look like that. The 5 is going to be, that's just going to be a straight line there. We need to find this intersection point. And that intersection point is actually going to give us our answer. By the way, just a note, if you try to put this into Desmos, the first one you can actually just write, you can either write 2 to the x or you can write it as y equals 2 to the x. The second one you are going to want to write as y equals 5. You can't just put a number in. So once you find what they are when you graph them, if you use Desmos, it actually is, it's pretty easy to find it. You'll get the point 2.3225. I'm going to show you eventually how to do this on a graphing calculator. I want to wait till everyone's in the class, or most people are in the class, before we do that. So remember, we're solving for our x, we're not solving for the y, so we're going to look at that x value, which actually is the same thing as we got there. So that's a little trick that you can use for solving an equation. You don't really have to do very much work at all. You just use your graphing calculator or any other graphing utility. So for this one, you're going to probably really be happy that you're allowed to use a graphing utility for this type of problem, because it's a little complicated if you do it by hand. I'm going to show you both ways. So my first way of doing it, the graphing utility, again, you are going to put into the first y value, or into y1, you're going to put 5 to the x minus 2. Into y2, you're going to put 3 to the 3x plus 2. If you're doing it on Desmos, you can actually just type in 5 to the x minus 2 and 3 to the 3x plus 2 straight into the Desmos app. I will tell you though, if you do this on Desmos, make sure that you put these exponents in parentheses, otherwise you might get something a little different. So when you graph this, they almost look like they're going towards the same place. So you're going to have one that looks like that, and you're going to have one that looks like that. They look pretty close, but you will find that they actually intersect at the point -3.2120. And remember that we're trying to find our x value, that's what we're solving for. So my answer here is going to be x. Actually, I usually put approximately equal to, because this is not the exact value, equals negative 3.212. So I probably should have done it the other method first, because this way is nice and quick. The other method of doing this problem is a little bit longer, but it is still one of my favorite ways of doing these problems, and actually this is one of the only ways that you can do this problem other than graphing. You are going to take the ln of both sides again, just like you did previously in the problem before this. You move your exponents out front. Unfortunately, once you have that, there is no real easy way to simplify this. I usually like to change my ln of 5 and ln of 3 to a decimal and then distribute it out. It makes the problem a little bit nicer. I'm not going to do that this time, but it is one of the recommended ways of doing that. From here, we're going to solve for x. Now, if you remember when we did inverse functions, this actually is a similar type of solving situation. We're going to have to move all of the stuff with an x on one side of the equal sign and move the stuff without an x on the other side. So I'm going to distribute this ln of 5 and this ln of 3. Please don't forget the distributing part. A lot of people, they just put the 2 times ln of 5 and the 2 times ln of 3, so don't forget that step. So I get x ln 5 minus 2 ln 5 is equal to 3x ln of 3 plus 2 ln 3. So then, like I was saying, we're going to move all of our x terms on one side and we're going to move all our constant terms onto the other. So I end up getting x ln of 5 minus 3x natural log 3 is equal to 2 ln 3 plus 2 ln 5. If I factor out an x, I then end up with this right here on the left. Keep my right-hand side the same. And so my final answer for x, this is going to be my exact answer, is going to be 2 times the natural log of 3 plus 2 times the natural log of 5, all over natural log of 5 minus 3 natural log 3. And hopefully we didn't make any mistakes in the meantime. That's always something to be aware of when you're doing this. Just go slowly. And if you evaluate this on your calculator, you should get negative 3.212, which is what we got on the right-hand side. So you might find that for these, the graphing utility might be your preferred way of doing it. Like I said earlier, the other way to do this one is once you get to this step right here, you can use your calculator to evaluate the ln of 5 and ln of 3 values, and then it's a little easier to combine your like terms. It's still not easy, but it's slightly better. So that's the other way to do that.